Hello students, welcome back to my YouTube channel, Data Shah. In this lecture, we'll be talking about another question of quadratic spline interpolation. So let us consider the data. The following data is given to us. So let me make a table quickly. Okay. So I have here x and the y, the values, and 1, 2, 4, 6, 7. Exempt this one, please. And the y values that I have is 5, 11, and 32. What you need to find out here, these are the unknown values. It is not given to you, okay? So the data is fit by the quadratic spline interpolants given by, let me write the fx, ax minus 1 from 1 to 2, then minus 2x square plus 14x minus 9 from 2 to 4, then bx square plus cx plus d from 4 to 6, and lastly 25x square minus 303x plus 928 from 6 to 7. So this is the quadratic spline interpolants where A, B, C, and D are constants given to us. Now, there are two questions in this particular question that could come. First question that is important is, these are the unknown values, right? Y at 4 and Y at 6. Okay, so what you need to do is, first of all, we have two parts in this particular question. So I'll be taking both the parts, right? So you need to find out the first part, okay? So you need to find out the value of Y at 4 and the value of Y at 6. Now you don't know these constants A, B, C, D, right? But still they're asking you to find out these values, the Y at 4 and Y at 6. So how would you find that? What is the way to find it? Now, we know that for the quadratic spline interpolation, by the definition, we know that each spline passes through their points. That means this is my S1x, right? This is my S2x. This is my S3x. This is my S4x. Now to find the value of Y at 4, I hope you could understand that what you need to find out, that 4 is passing through two splines, right? Spline interpolant, S2 and S3. So for the S3, we have constants that are unknowns, B, C, and D. So how would we find that? That's not possible. So what I can do is I can substitute x is equal to 4 in the second spline, that is S2x. And from there, I can calculate the value of y at 4, right? So here, how to find the answer? Let me just quickly write this. As we know, or I can write as Sx is a quadratic spline. So each SIX will pass through all the points. So points here we have this is our x0, x1, x2, x3, x4. So we have 5 points, right? Y0, y1, y2, y3, and y4. So because there are 5 points, so our n is coming out to be 4. So therefore, we have 4 spline functions. I hope this point is clear to you, right? Now, in this, after this, we could how to find y at 4? Y at 4, we could find the value y at 4 is equal to S2 at 4. So that's very easy to calculate. So S2 at 4 would be minus 2x square plus 14x minus 9. So when we'll calculate, this is coming out to be minus 32. Sorry. So the final answer that we would be getting here would be 15. So this is the value of y at 4. Similarly, to calculate the y at 6, now the 6 point, as we know, x3 is passing through s3x and s4x both. But s3x, again, we have the unknowns, we cannot find it. So what we'll be doing, we'll substitute the value of 6 in s4x and we can get find the value of y at 6. Okay. So similarly, y at 6 we could find using S4 at 6, that is equal to 25x square, that 6 square. So when we'll find this is 25 into 36 minus, so the final answer that we are getting here is 10. So this is my value, y of 6 at 10, and y4 is coming out to be 15, right? So these are the two values, and this is our first part that you need to find. Okay. So easy and simple, right? So without finding out the constants, you can get this question without finding out the constants. Now, if the constants need to be found, then what you have to do? So that's our second part, to find the constants or any of the constants. So you can follow the steps. So to find A, B, C, D, the unknowns value. Now how to find this? Now we'll be applying the second condition of the spline. That what is the second condition? That the slope of the splines are equal at the break points, right? So the break points here we'll be talking about. What are the break points? Like these are the break points, right? So let me highlight with like 2, 4. Okay, so S1 dash X and S2 dash X, they would be equal at the point 4. Similarly, S2 dash X and S3 dash X would be equal at the, that would be equal at the point 2, and S2 dash X and S3 dash X would be equal at the point 4. So using this, we could find out the values, right, at the different splines. So let me take this. So as I'll be using the same, Sx is a quadratic spline. So the slope of the two splines are equal at the break-even points. So the break-even points that we have here are, that is x1, x2, x3, that is 6. So we have these 3 points. So we'll be getting 3 equations and we could find out the value as well. So now quickly I'll write here. So that is S1 dash at 2 would be equal to S2 dash at 2. So S1 dash would be 1 dash would be equal to 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 1 da S1 dash is just A, and we could find out the derivative of this as well. So let me just, S1 dash would be A is equal to um, minus 4x plus 14. So I need to put x is equal to 2. So I'll just put it in the another step. So A is equal to minus 4 into 2 plus 14. So I'll get A is equal to 6. Very easy and simple. Now on the similar basis, I will calculate the another value. S2 dash at 4 is equal to S3 dash at 4. So S2 dash at 4 is same. So that's minus 4x plus 14. And S3 dash that I'm getting is 2b x plus c. So at 4, this would be minus 16 plus 14, 8b plus c. So this is 8b plus c is coming out to be minus 2. So I'll be using this condition because I'll be getting here another condition. Lastly, S3 dash at 6 would be equal to S4 dash at 6. So 2bx plus c is equal to 50x minus 303. That's 2b at 6 plus c. 50 into 6 minus 303. So this is 12b plus c. This is 300 minus 303. So I am getting here 12b plus c is equal to minus 3. So what we can do, I can take the value of c from here and I can substitute here. So this is equal to 12b minus 2 minus 8b minus 3. So here I am getting 4b as b is equal to minus 1 upon 4, right? So let me just quickly, okay, I'll do it later. So after calculating this, when you'll substitute here, so put b is equal to minus 1 upon 4 in this equation 1. We get c as, so this is minus 2 plus 2. So I am getting here c as 0. So these are my three constants, um, a as 6, c as 0, and b as minus 1 upon 4. Now, the only value that is left is d. So very easy and simple to find it. Now, I have used this particular um, condition to find out the value. So now, how do we find out the value of d? Now, as we know, d is the constant that we have in the S3 spline, right? So now I'll be using a very simple technique here, as I have used it here, that the each spline function is passing through all the points. So the spline function for y3, as we have calculated, right? So y3 is equal to y at 6, right? So y3 has equal to 10. Either you can use that and you can find it from here only, put the value of 6 and you can get it, right? So I'll do that quickly. Now S3 x is b is coming out to be minus 1 bx square plus cx plus d. So that's minus 1 upon 4x square plus 0 x. So that's minus 1 upon 4x square plus d, right? So S3 at x3 is S3 at 6. So now I have already calculated the value as 10. So that's minus 36 upon 4. That's 9. So I'm getting my value D as 10 plus 9. So again, the value, the constant, very easy to calculate. So like this, we can calculate the values. So this is another question of the quadratic spline where you can find out the constants, or you could find out the unknown values using your definition of quadratic spline. So thank you so much, everyone.